Hello, welcome back to our channel. I am Anisha, your maths faculty for class 12th. Okay, we are doing chapter number 5 of class 12, continuity and differentiability, in which we have started exercise 5.1 and we have covered the question till question 11. If you guys like interested to see any of this question of like from exercise 5.1 from like 1 to 11, you can just see my previous videos. Now in this video, our main aim to complete question number 12 and 13 of this exercise 5.1. Now let's begin. Okay. Okay, so question number 12. Let's read our question. Okay, in this question we have to find all the point of discontinuities of f where f is defined by. Okay, we have to find all the point of discontinuities. Okay, so as you can see, our function is defined like this, and like it is like separating or like taking different functions for x less than 1 and for x greater than 1. So in this, our aim will be to find the point of discontinuities. For that, what we will do? What we will do this, we will find the continuity of a function at each and every point. Now, in this case, as the function is dividing in three, like you can see for less than 1, it is sum. For less than 1, it is different function. For x greater than 1, it is a different function. And for equals to 1, we will like always, when your function is splitting at a particular point, so we will have what we have to do. We have to just divide it in the cases. Okay, so here what will be our case 1? I think you guys can easily guess. So for this case 1, whenever x is strictly less than 1. Okay, just take any x equals to a such that our a is less than 1. A is less than 1. So to check the continuity, what will we do? We will find our its function value, we will find its limit value. If they are same, then it is continuous. If they are not same, then we will say it is discontinuous. So its function value, that is f of a. So for less than 1, it is a raised to 10 minus 1. Now find its limit value. So this will be limit of x tends to a f of x. So this will be limit of x tends to a x tends to a. So here function will be x tends to a minus 1. So this will be a raised to 10 minus 1. As you can see, function value and limit value is same. So from here what you get, what you have seen, that f is continuous at a. And since this a is nothing but any point such that our a, this is less than 1. So now as I have started with the arbitrary a, so this a can be any number less than 1. That means it can be 0, also it can be minus 1, it can be minus 2.5, it can be 0.5, it can be any number less than 1. So from here what we conclude, that our f is continuous for any x less than 1. Now, what will be the case 2? So, here our case 2 will be when our x is strictly greater than 1. So, for strictly greater than 1, we will do the same thing. Just start with the arbitrary point, check its find its function value, find its limit value, and they are same, then they are continuous. At that point, the function is continuous at that point. If they are not same, then we will say it is discontinuous at that point. So, this will be like try by yourself. Try by yourself. It will be like easy for you. It is just the same thing we have did in the case 1, and just function is changed. So from here also I will just tell you the conclusion, that f is continuous for each and every point x greater than 1. So from here what we get, our f is continuous for any x greater than 1. Now we are like in the domain. What is it here? As you can see, our domain is polar. So in the domain we are only left with the point x equals to 1 where we have to check the continuity. So this should be our last case. Okay, which will be case number 3. So our case number 3 will be when our x is equals to 1. So for that, first we find our function value. As you can see, our function value for equals to 1, it is defined as x raised to 10 minus 1 there. So this will be 1 raised to 10 minus 1, and 1 raised to 10 is nothing but 1 minus 1. So this will be 0. So function value at 1 is 0. So now we will find its limit value. So similarly, I like just to suggest you every time that when you have just your function is splitting in, like for left hand it is defined something else and for right hand it is defined something else. So what you should do is always find your limit by using the left hand limit and right hand limit separately. So as you can see, as x equals to 1, when you are approaching from the left, so your function is defined as x raised to 10, right? Yeah, x raised to 10 minus 1, and when you are approaching from right, then your function is defined as x square. So we will find its left hand limit. So its left hand limit, here your left hand limit will be limit x tends to 1 minus f of x. Here where f of x is defined as x raised to 10 minus 1. This is nothing but 1 minus 1, that is nothing but 0. Your right hand limit will be limit x tends to 0, sorry, x tends to 1. Okay, your limit is x tends to 1 positive. Your f of x is defined as x square, so this will be nothing but 1. Well, now see what you get, that your left hand limit is not equals to your right hand limit, right? Your left hand limit and right hand limit both are not same. So from here what you get, that limit not exist. It's just basic concept that when your left hand limits and right hand limits are not equal, then the function is, sorry, the limit does not exist. Since the limit is not existent, so there is no point to check your like equality between the function value and the limit value. So from here what we get, so from here f is discontinuous at x equals to 1. So what will be the conclusion? As you can see, we get only one point where the function is discontinuous. So our conclusion is f is discontinuous only at x equals to 1. So for this question, the only point of discontinuity will be x equals to 1. Now let's move to next question. Okay. So what is here what we have to do in this question? Here also we are asking you the same thing, but the language is just changed. Okay, here what you are asking, that is the function, that is a function is defined by this is continuous function. And what is the definition of continuous function? Continuous function means f is continuous function. F is continuous function. We know that continuity at a point, but when your function is said to be continuous function, if f is continuous for any point or continuous at, I will, if I correct myself, so it will be our function is function f is said to be continuous function if f is continuous at any point in its if it is continuous at any point in its domain. Now let's begin. As you can see here, as the function is defined for each and every point of the real number. So from here, what you get, your domain is nothing but whole R. This is your domain. Okay. Now let's see the continuity. Okay. So the as a function, as it is divided like as in the previous question, same as question 12, it is divided in two cases. Like for x less than 1, it is divided different function. For greater than 1, it is different function. Then we have to just left with the checking the continuity at x equals to 1. Now as you can see, if I try to like explain you by like if I want to give you just hints. So for less than 1, it is a polynomial function. For greater than 1, it is also a polynomial function. And we know that polynomial functions are always continuous. So for x less than 1, it is continuous. For x greater than 1, it is continuous. Now look at x equals to 1. So for equals to 1 is the point where we have to like do the calculations. But let's do the theoretically properly for each and every point. So first we have case 1. What is case 1? Whenever x is less than 1. So start with any x equals to a less than 1. So first find its function value. So its function value, it's defined as x plus 1, so x plus 5. So this will be a plus 5. Now its limit value, that will be limit of x tends to a. Its function is defined as x plus 5. So this will be nothing but a plus 5. So as function value and the limit value both are same, from here what we get, f is continuous at x equals to a. Since this a is an arbitrary number less than 1. So from here what we get, f is continuous for any x less than 1. Now take the case 2. What is the case 2? When your x is greater than 1. So similarly, start with any point that is and any number that is less greater than 1. Find its function value, find its limit value from here. Like it's for you. You should calculate it. Do it. Okay. So it's easy, like same as the same procedure as you have did in the case one. So from here, I will just tell you the conclusion. From here also, your f is continuous for any x greater than 1. Okay, so in the domain point, we are just only left with the point where x equals to 1. Like for greater than 1, it is continuous. For less than 1, it is continuous. So we are left only with the point when x is equals to 1. Now take it as a case 3. So our case 3 will be when x equals to 1. So first find its function value. So f of 1, this will be for equals to 1, it is defined as x plus 5. So this will be 1 plus 5, that is nothing but 6. Now we will find its limit value. As you can see, for limit value at x equals to 1, when we are approaching from the right and we are approaching from the left, we have like different functions are defined. For when we are approaching from the right, we have x minus 5, and when we are approaching from the left we have x plus 5. So if we have to find the continuity at that point when you are approaching from like right hand and left hand, then you have such that you have a different function. So for that, what is the main logic? You should always find your left hand limit and right hand limit separately. So let's begin with that. So our left hand limit will be limit x tends to 5 minus here our f of x is nothing but x plus 5. So this will be okay. We have to check it not at 5. Sorry, my mistake. We have to check it 1. Okay, when x is approaching to 1 minus. So this will be x plus 5. So this will be 1 plus 5. This is nothing but 6. Now move to right hand limit. So our right hand limit will be limit of x tends to 1 positive. Function is x minus 5. So this will be 1 minus 5. As you can see, this will be minus 4. Now see, from here what you get, your left hand limit is not equal to your right hand limit. So what does it mean? That limit not exist. And when limit not exist, then there is no point to check their equality between the function value and the limit value. So from here what you easily conclude that f is not continuous at x equals to 5. Sorry, x equals to 1. Why I'm like forcing on pi, because I think there is a constant of pi, that's why. But we get that f is not continuous at x equals to 1. So what now what was the question? What was the question? Our question is that like we have to say whether our function is continuous function or not. And from the definition we have that it is continuous function when it is continuous at each and every point of its domain. But as you can see, f is not continuous in the whole domain. So from here, what will be the conclusion? Okay, I will write it in the next page. As it is not continuous on each point so of the domain, so what will be our conclusion? That f is not a continuous function, not a continuous function. Okay, that's all for today's video. I hope you guys like this video. Please watch each and every questions if you have any like queries, and feel free to ask your doubts in the comment section. I will like solve your doubts as soon as possible. And till then, goodbye. Please like, share, and subscribe. Thank you.